So we're going to start looking at probability of independent events. And just a reminder what independent events are. They are events that are not affected by previous events. So the probability of one event doesn't affect the probability of the next event. Okay, so the probability for the example I gave here was the probability of the next coin flip does not depend on any previous coin flips. Okay, so a dice roll, coin flip, these are what we call independent events. One does not affect the other. So what's the probability of rolling a number 4 on a 6-sided dice and flipping a heads on a coin? Okay, well this is a 2-event probability, so we can, draw our sample space out for this. Okay, so we have, 1, 2, 3, 4, 5, 6 as possibilities for our dice roll. And for our coin flip, we can have heads or tails. Okay, so what we want to do is we want to know what the probability of rolling a 4 and a heads. Okay, so if we look at that, this is 4 and heads. Okay, so this one event out of possible 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So that's going to the probability is going to be, so probability of 4 and heads is going to be 1 out of 12. Okay, so we've done this before with a sample space, but we're going to try this slightly differently. So what we could do is we can do this. So this works with consecutive events. Okay, and when we deal with independent events, it's very nice because we know the probabilities of events and we don't have to worry about the order of things happening. So we can do it in a slightly different way. We can multiply probabilities. Okay, so it looks like this. The probability of heads and number 4 can look like this. The probability of heads times the probability of rolling a number 4. So the probability of heads is 1/2, and the probability of rolling the number 4 is 1 out of 6. And we can see that because these are independent events, we can actually calculate the same probability by multiplying these two probabilities together. So these are equivalent. So this is the main idea, is that although this is the most reliable, so when we can see the sample space, that's always going to be the most reliable way of doing it. There are ways to deal with these types of consecutive event probabilities where we could actually multiply probabilities together.